how to balance chemical equations in 5 easy steps. Step 1. Count the atoms on each side of the equation. Let's count each type of atom. Sulfur, I have 8. Oxygen, I have 2. On the product side, sulfur, I have 1. And oxygen, I have 2. Note, if there is nothing after an element, we assume that to be 1. And that's it. We're done with the first step. Smooth. The big rule for balancing equation is that we can only change the coefficient, those of the numbers in front of the atoms. The number after the atoms, the subscript cannot be changed. So let's balance this equation by changing the coefficients. If there is no coefficient written, we assume that is 1. So right now, there is a 1 in front of each these terms. We can see that we have 2 oxygen on each side of equation. So the oxygen is fine, but the sulfur atoms, we have 8 on the left side, the reactants, and only 1 on the right. To fix that, I can change the coefficient in front of the sulfur on the right and make that an 8. So if I put an 8 here, that means 8 times 1 sulfur, that will give me 8 sulfurs. And my sulfurs on both sides are 8. But this 8 here is also times 2 oxygens, and that gives me 16 oxygens. So I fixed this off first, but the oxygen is imbalance. I can change the coefficient here though to 8 because 8 times 2 equals 16. So now I have 8 sulfur on each side and I have 16 oxygen on each side of the equation. This equation is balanced. Step 3. So you don't forget, only change the coefficients. Let's try another problem. So on this equation we have 2 hydrogen, 2 oxygen, over here 2 hydrogen and 1 oxygen. How about, let's see, I'll put it 2 right here. So 2 times 2, that gives me 4 hydrogen. But 2 times 1, that gives me 2 oxygen. So my oxygen is balanced now. But my hydrogen are messed up. What I can do over here is put it 2 in front of hydrogen. And now 2 times 2, that will give me 4. And now the atoms on each side of the equation are the same. This equation is balanced. Sometimes you have equation that looks downright scary. Yikes! But if we have a polyatomic ion on both sides, like the SO4 or the NO3, then we can consider that ion to be just one thing. Let's see how that works. So here is the equation and I've done accounting below. You can see I have 1 calcium here, 1 calcium over here. Then I wrote the entire SO4 as one thing, and I have 1 of those here and over here, and I have 1 Na, 2 NAs on this side, and over here 1 NO3, and I have 1 NO3, but that 2 on the outside means I have 2 of them, so I have 2 NO3. So if I put the coefficient of 2 right here, that means all I have 1 times 2, 2 NAs, but these 2 also multiply across. So 1 times 2 for the NO3, that gives me 2. And now everything is balanced. So by treating those polyatomic ions is just one thing, it makes a pretty simple equation. Let's wrap up with one it sometimes gives people problems. So we can see we have 1 carbon, 4 hydrogens, and 2 oxygens. Easy. Over here we have 1 carbon, and then we have 2 oxygens, and then we have 2 hydrogens. But be careful, we have to count this oxygen over here as well. So we have 2 plus 1, that will give us 3 total oxygens. I'll start by balancing the hydrogen. If I put it 2 in front of this hydrogen, 2 times 2, that will give me 4. But now I have 2 oxygens, plus 2 times 1, 2 oxygens. That gives me a total of 4 oxygens. But that's good, because now if I put 2 right here and change the coefficient, 2 times 2 equals 4, and now everything is balanced. This video is giving you the basic for balancing equations, but you've got to practice to gain speed and expertise. The more you practice, the more you become better. This is James De Guzman. Thanks for watching.